So this morning, we want to talk about the parts of a modeling project from conception to publication. Now, the first thing I would like to talk about has to do with, it's like my own is moving, your own is not moving. Now, the public health and epidemiologists has their wish lists when it comes to modeling projects. Okay, let's call it. So then the mathematicians have their wish list. So for the public health and epidemiologists during an epidemic, they want to, the public health authorities should be looking up for answers to the following important questions. What do they want to know? People who are in epidemiology, who are in public health space, who are in NCDC, WHO, what kind of answers are they expecting from us? What are they expecting to see from your results? So, you know, now, if you are, if you are publishing in a journal that is focused on epidemiology, or you are publishing in a mathematical journal, there are directions. And then, if you are talking to, let's assume that you want to go and present this this work in a conference in the US. They have paid for your flight. And then they want you to come and present this work. And then you find out that the audience are people from CDC, WHO, and all of that. You are supposed to put your slide according to the people you want to talk to. So you don't get there now, and then you begin to talk about bifurcation, stability, local, global stability, Lyapunov function, and all those big terms. So the people are looking at you that, oh, who is this man? They are confused because you are taking them into the abstract world. So they expect that you should speak a language that they can relate with. Are you getting me now? Like some of the people we have invited for the conference from outside Nigeria for this particular, for this conference from tomorrow, some of the plenary session. Do you know the question they have been asking me? Said, who are the audience? Which people are we to, are they going to talk to? So that they don't begin to talk something that off track. So you must understand your audience if you want to give a talk. If you're a mathematical modeler, you want to give your results to people, you must know the people you want to go and talk to. Right? So now you don't get there and begin to speak those foreign language, then they will not understand. So you talk about estimation of reproduction number, R0, or other epidemiological thresholds, R0. They want to hear, okay, what's the reproduction number of maybe measles or malaria in Borno State. They have not been to Borno State, but you have been there. They've been hearing about it, that there is always an outbreak in that place, and there is Boko Haram going on. How are they managing? They want to know what is going on there. So if you give them the picture, they'll be able to understand from the language. So, and then the qualitative nature of the spread. Now, in terms of the spread of malaria, maybe malaria or measles. Now they want to know what are the qualitative nature of the spread, the spreading speed. You know, I was showing you the rates at which the spreading speed, the exponential growth. How is it growing? Is it growing up to 1,000, 2,000, 3,000, 5,000, 10,000, 50,000 people have been infected? They want to know. Then when peak is attained, when are you going to get to the peak of the disease? Can you show them when the peak came? At what time? Did you arrive at the peak? Is it at the first month, the second month, the fifth month, the sixth month? Does it take 1 year to get to the peak before it starts dropping? Does it take 2 years to get to the peak? By the time it's taking 2 years, it means that a large number of people will have been infected. So, and then when will the epidemic die out? When is it going to die out? When is it going to get extinct from the population? Now, do we have multiple waves phenomenon? Now, multiple waves in terms of in a year, are there multiple annual peak, annual seasonal effect that we are seeing? Maybe it's not just in one time in a year that we are having the peak. Maybe we had one peak in March, and then there's another peak in September. Or maybe there are 3 peaks in a year of that particular disease. They want to know from your results. That's the interest. Then estimation of disease burden. Estimation of disease burden. This thing is not moving again, but it's moving from here. So, estimation of disease burden. Now, the interest is also, what is disease burden? Mortality. They want to know how many people have died due to the disease. How many cases have we recorded within the space of the year? 2,000 cases, 5,000 cases, 50,000 cases. They want to know what is the prevalence of that disease in that location. You know? Because the interest will now be that, okay, the way the disease is spreading, if it continues to spread, will it not become a pandemic? Will it not spread all over the world? Will everybody not be infected? These are the things. So the expected number of infection, that is number of cases, number of disease-induced deaths. They want to know the expected number of hospitalization. How many beds do you have that will contain? Let's assume that there is an epidemic. Are we going to have enough beds where you are going to put people? Or people will be sleeping on the corners. You put people on the corners and put their bed there. Just like during COVID, I was watching countries like Iraq. During COVID, people were sleeping on the door. I mean, at the foyer. Different parts of the... they could not find a bed for them because the whole health system were collapsed. So, now, evaluation of control strategies. They want to know. Then, targeted strategies. Herd immunity. Like what I said the other day, herd immunity. That means immunity of others can work for me. How many people do we need to vaccinate to get herd immunity? Right? So, cost of intervention individuals over a large geographic area. Experiments conducted in laboratories are often inadequate simply because of the huge difference in scale. How many people do you want to capture like guinea fowl inside the room and begin to collect their blood and all of that? It's not possible. It's not ethical. So for infectious disease in human, a large-scale experiment may be impossible or unethical. So existing data set about disease may not be complete or accurate enough for the statistical analysis to be reliable. For instance, there will be little or no disease surveillance data available on infected people who are asymptomatic. You know that? Now, we don't have data on number of people who are asymptomatic for malaria in Nigeria because they don't go for tests. Yes, now, if you are not feeling anything, do you just go, okay, come and test me now? You don't have the time. Come and test you for what? You don't feel sick. Even in the hospital, they will ask you, what's wrong with you now? Why do you come here? You understand? You have money. The little money you have, you are managing it. You now go to the hospital. Oh yeah, come and test me. When you are not feeling anything, you can eat, you can drink, you can walk, you can see, you can move around. How many of us this 1 week you have gone to hospital? Come and test me for malaria. You have gone there. Now you won't go because you are not feeling sick. So we don't have data on some information. The asymptomatic, we don't have data. Since repeated experiment and disease outbreak in a population are rarely possible, disease surveillance data often represent a single outbreak with a large amount of information. So statistical analysis of high-dimensional data from small samples is a challenge since statistics theory relies on large samples. Now, mathematical wish lists. People who are in mathematics, what's their interest when they are modeling? Their interest is characterize the qualitative dynamics of the model. System system of differential equation. So they are looking for existence and asymptomatic stability of solutions. They are doing mass for mass inside modeling. Type of solution, equilibria, periodic. That's what they are looking for. Stability, local and global stability. So if I'm talking to a mathematical group now, I will be talking about stability, equilibria, and periodic. I will talk about those things. Those are the things that then they will begin to ask questions. What is the boundary of alpha? Then I'll go to the board. I will begin to drag it. Like Caputo now is there. He will ask question. Prof, how do you mean that cos alpha theta is less than 1? Then, and those things, at the end of the argument, you just go home and then you are not getting any grant for that, you know. So, condition for persistence and elimination of disease. That's what we are looking for. And then you want to talk about bifurcation. So you are talking about forward transcritical bifurcation. So this one is saying, no, it's not forward, it's backward. It's not forward, it's downward. That one is hanging. And then you are there for the next 2 hours. You are still struggling on one bifurcation. Before you know it, the time is gone. And they say they clap for you. Go and sit down. All of you mathematicians, you meet yourself after service. So they look at up bifurcation. Does the system exhibit chaotic dynamics? Right? So analysis require the use of dynamical system theory and techniques. Now, Caputo came to challenge me. Said, sir, you published a paper when I got here now. Caputo, stand up. He said, you published a paper in Uniben. We printed your paper. And we're looking at the paper. ICAMMDA, they are running for mathematics. They didn't put mass in the paper. They didn't put mass. Where's the mass? Where's the mass? Where's the mass? Let's see the mass. I was not like, if there is no mass, how are you going to get these results? So, people, mathematicians, they are looking for mass everywhere. Mass, where's the mass? Where's the mass? So that's why they began to ask questions. Now, Lyapunov function, comparison theorem, perturbation theory, positive matrices, Poincare-Bendixson theorem, center manifold theory. They are looking for that. And the goal, what's the goal? To develop new mathematical theories and techniques for handling large systems of differential equations. But the challenge is that most of all these papers in mathematics, they are not towards developing new mathematical theories. They are just copying the same thing. So when you see the paper, positivity, boundedness, invariant region, reproduction number, local stability, global stability, sensitivity analysis, optimal control, cost effectiveness. So, and then publish. We concluded that Benue State should apply all the various control in this world so that malaria can come down. When you ask the man, where is the data of Benue State? He doesn't have it. Are you getting me now? So say this model can solve all the problems. It's globally so mathematicians are very powerful people. So, but I think from now, it should be now, our goal should now be, are we ready to develop new mathematical theories and techniques for handling large systems of differential equation? Now, going forward, steps in a modeling project. Now, number one is that development of the study concepts and question. Development of the study concept and question. Now, every modeling you are doing that does not come from a question from epidemiology or biology of the disease, you have not started. Because when you don't get the question, you will only be repeating the same process of method. But when you come from the point of view of question, that is, so the question now does not come from maths. The question comes from the biology the epidemiology, the public health of the disease. So you are developing the concept. That's you know, when we started, I said you should write concept notes, right? From the concept notes, when you are applying for TED fund, you know, you apply and ask for concept notes. After the concept note, you also put up the proposal, the full proposal. Now the question is, how many mathematicians in Nigeria has been able to win TED fund? Because we don't usually know how to write in the language to solve some of this, and that was why we created these 17 sustainable development goals, so that we can discuss it. The problems are coming from there. They are not coming from maths. So you must be able to know where your problem is coming. So the question you want to answer is not from mathematics. It's not from positivity. It's not from boundedness. Because boundedness, positivity, they are established theories. You are not the one that did it. You are only using it. You are using them. They are not your own. Although in your model, they can, what we call the primary analysis. There are things you must do. Like you must carry out positivity to check. What's it called? Bounded region and all of that. Positivity, invariant region, all those things. You must check. You must find the reproduction number. They are primary analysis. They are traditional. But that does not make your work publishable. So the point at which your work becomes publishable are the point of your question. If your question is able, your model is able to address the question, then that's where your work becomes publishable and reasonable. Even if it's theoretical and you don't have data, you can come from the point of question. So you develop the study concepts and question. And then, now, you look at literature review. Number 2, literature review. Literature review. Now, you cannot, if you are having a concept or you are having some question, the answer to all those things is from literatures. Anything you are thinking about, even if it is conceptual, you are just thinking about, okay, people are having a particular disease, like somebody was discussing lung cancer with me. Maybe it's just coming to your mind. The first thing to do is to go and check literature. Is there anyone that have done it before? You have to find out. If nobody has done it before, are there likely things that people have done? If nobody has done the exact thing, are there likely work that has been done in that area? Okay? You need to ask. So, if you find literatures and you gather them together, you'll be able to know what and what have people done, and that can guide you going forward. That means you are going to start from the known and then you move to unknown. Okay? So you need that to be able to do the work. Then number 3, data collection. What do I call it? Data collection. Now, in modeling, if your work is going to advise policymakers, now you need data. If you want to predict, you need data. So data collection are in 2 forms. It could be primary data. It could be secondary data. If it's primary data, it means that you are going to develop the questionnaire yourself based on the problem you want to solve. But if it is secondary data, there are established platforms. You have NCDC, you have NMEP, you have Federal Ministry of Health, you have various public health spaces in Nigeria or outside where you can get data, or CDC. So then the 4th one is, after data collection, you begin to think about construction of model framework. I've collected the data, I've gotten the literature review, I've developed the study concepts and question. Then what is the direction of my modeling based on some of these things? Now, don't forget that in the course of also studying the literature, you are going to get some gap in knowledge. So that is going to link up with the concept you are coming up with. There are gaps in knowledge. So from there, you begin to see, okay, this is the way my model is going to be structured and all of that. And then the fifth one is model analysis. So you begin to say, okay, am I going quantitative? Am I going qualitative? Now that you have data, sometimes you could do both, depending on your background. But for those people who are in public health, I think the direction or other fields apart from mathematics, the direction should be quantitative. But for people in mathematics, they still want to do their qualitative. It's fine. And then you still do your quantitative analysis. So at the end of the day, you are getting results from both directions. And then, like I said yesterday, you do model selection. So in model selection, you are building more than one model. Candidate model, you are having 2 or 3 models or 4. And you want to compare which one is fitting the data most. And then for you to establish that, you need some criterion, that is AIC, Attacker Information Criterion, to be able to do the estimation of which model is the best for this particular data. And then you carry out model validation. Like I said yesterday, how is your modeling result or output, how is it related to what is going on in the real world? Is there any relationship? After your model analysis, your model selection, can you say that what you have done has something to do with what is existing in reality? Then the 7th, manuscript. There is no data. What do you do? Number 1, purely theoretical studies. If you don't have data, purely theoretical studies without data collection. 2, parameterization based on published studies. So it means that your parameter estimation will be based on what people have done, what people have published. You can use published work to get some data. And then you have to also know that in doing that, there are 2 things. So for you to do parameterization based on published study, you need to do systematic reviews and meta-analysis. That means you check publications that are relevant to the parameter you need. So in doing systematic review, you know what we call systematic review? You are painstaking. Like you can get more than 10 or even 50 papers that have worked on that particular project, and you are collating them together to be able to get what are the parameters people have used over time from different locations. You know, somebody has done the work maybe in South Africa. Somebody has done the work in Benin Republic. Somebody has done the work in Kenya. Somebody has done the same work in Burundi and different parts of Africa. And you are now doing it in Nigeria. So you have about 50 papers on that party because you have carried out systematic reviews. Systematic review is different from literature review. I don't know whether you know that. So in systematic reviews, you are systematically checking publications in relation to what the exact thing you want to choose, you want to check, you want to find out. And then under parameterization based on published studies, you can also check some experimental and field studies. Like for you to get the incubation period of a particular disease or latent period or infectious period, these are experimental studies. They are from experimental studies. So you need publication from experimental studies to get the values of those parameters. Then you also have the opportunity, if you are going to use data. Number 3, you know, the other one is without data, but this one with data collection. Number 4, you are going to construction of model framework. That's, you can go in the direction of dynamic equation and code. You write a code, you develop a mathematical model, dynamic equation, and then you write a code, maybe an hard code, just like you did this week. And then you show relationship between parameters. In the course of writing dynamic models, there are parameters, the density is equal to minus beta si minus mu s. Then the identity is equal to beta si minus alpha plus mu bracket I. The identity is equal to minus alpha I and all of that. And then you are relating the parameters together. Then number 5, model analysis and selection. So under this, you are doing parameterization. If you are going, so this one is quantitative, while this one is qualitative. Now, the quantitative one is you are having data and then you are using it. So in the course of doing that, you are fitting and you are parameterizing, and that's model calibration. You are fitting and you are adjusting your parameter to fit your model. That's what you do in calibration. So, and then you also carry out simulations and debugging. So simulation in the sense that you can carry out some scenario analysis. You simulate to see some, to answer some question. You subject your model equation to certain question. If I use 80% of fascination, what will happen? How many people are going to, how many cases are going to be averted? How many mortality? What is the amount of mortality that will be averted? So these are things you can look at. Number 6 is model validation. Model validation. Model validation. Like what I said yesterday, validation comes when you have to relate your model with what is going on in the real world. Now, sensitivity analysis is part of it. You know, your parameter, you have a parameter and you want to look at what are those parameters that influence the model most. You want to check that as well. And then you go to manuscript writing and submission. Now, under development of, so with data collection, what are those things you can do? So if the data already collected for other purposes, now the data you have gotten is not collected because of you. When they were collecting it, they didn't have you in mind. Do you know that? So they might not factor some of those things you are thinking about. You are thinking about something, but the people in epidemiology are thinking about something. So you need to find an intersection. What do? Focus only on analysis. Analysis of the that. First of all, data analysis. You have to see the data, the pattern of the data. Try to get what is the pattern of this data that I'm seeing here. And you cannot see that pattern inside an Excel file. All those numbers you are seeing, they are not enough to show you the pattern. You need to do visualization. So the next thing is to need to understand data limitations and quality. You have to factor that into play when you are using data. Because the data they have given you, they didn't collect it because of you. Now, then they need to adapt modeling to the available data. So how do you adapt? That's what you have been taught during the parameter estimation. How do you use your modeling to capture your data? You capture your data using modeling. So, and that is parameterization. There are different methods. One of the methods you have been taught was the least square method. Now, number 2 is data collected for modeling projects. So that means that if you are carrying out the modeling work, you can also collect data for that particular modeling project based on your question. So data collected for modeling projects. The other one, the first data is that data already collected for other purposes. There are 2 different data now. You are having a data in your hand. That's secondary data. The one you got, like some of those ones, maybe some of you are doing measles or Lassa fever, you have gotten some data in the course of, or cholera. Those ones were not collected because of you. So you use them according to what you have there. But now you want to do a project, maybe PhD work or a research for like longer number of time. Then you need to collect some data. You need to collect some data, right? So in collecting such data, you know, like I have people who are doing, some of my students who are in parasitology and what's it called? No, parasitology. 2 of them in parasitology. So, is it okay? Okay. So parasitology, they're in parasitology. So they needed to collect some data to feed it into their modeling studies. They are doing modeling. So some of you who are doing modeling, you can also collect data. So the only thing is that it may be time consuming. You are going to do, because that should even be the first thing. Once you have known the question you want to answer, you can collect data and then you can control the quality of the data by yourself, because you are the one collecting it yourself. And that can give a better result, sincerely. So doing that, modeling is generally more straightforward. So it will be easy for you to work on the data, get results, and then you can tell the story of your data. Do you know that? You can tell the story of your data. The data you didn't collect, you can't tell more stories about them. Now, development of the study concepts. The study concept. You want to develop the study concept. Number one, what is your question? What is your question? You must come out with a question. Right? You must come out with a question. Now, in your various classes, I'm going to come there today and I'm going to ask each of you in all the 7 groups. Now, you are working on measles. I want people to come out with questions for me. At least 1 or 2. Just 2 questions. Different from what you are doing. Before I come, I'm going to come to your class. I want to have 2 questions from each of the classes on measles. 2 questions on measles. Not modeling questions. If I see develop mathematical, that's not question. That is method. That's method. So now the next thing is, why is it interesting? Why is your question interesting? Why is it interesting? So you must be able to tell us, why is what you are doing, why is it interesting? Somebody told me yesterday he's working on sickle cell and tuberculosis. PhD work. I said, this is a conflict and crisis-oriented model. Because somebody is having sickle cell, and then you now add TB again, and you are modeling it. By the end of your 3 years work, that person is gone. So that's why some of us who are doing mathematics try to, if you don't want to bother yourself reading the biology, it's not even good for you. You understand? I read the biology a lot. I'm not a biologist, but I have to read the biology because of my work. I have to read the biology because of my work. I have to get the biology. I have to get the language. I cannot just want to work in agriculture now. I just pick up. I have a student who wants to work on cassava mosaic. You have to understand cassava, everything about cassava, crop science of cassava. If you don't understand it, don't come. Because you will just be telling story that does not exist. Are you getting me now? So these are things that we need to get, because you will not be able to drive your points to people who want to buy your product. You can't convince them. I'm hoping that next year, by the grace of God, we'll be talking about how to write grants in modeling. You want to get modeling grants. Are you getting me now? Because you see, all of these things are possible. Do you know that there are lots of openings. You can get down to carry out, even if it's just $10,000, to carry out a project. But you write a good work. You put it up very nice. Somebody is saying, I want to buy this. I want to pay for this. Not just doing something. So that's why we should learn the right way to do it. The conventional way, not the local way we are doing it. Conventional. When I mean conventional, it means that if you go to Harvard, the same way you find people doing it. If you go to Oxford, the same way you find people doing it. Let me tell you, I must tell you this today, that everything we are doing here is world-class standard by the grace of God. World-class. You can check anywhere in the world. Now, the reason is because we don't want Nigerians to look at a white man and then you are looking down like animal. You know, animal don't look up. They are always looking down, looking for something, a polo, earthworm, all those things. But you want to look up and say, yes, what you said there, Professor McPherson, is wrong. Eh? Say this black man. And you go to board and you are proving it for him. Something has changed. Then you want to travel from UK to come and learn from you. So that's the kind of thing we want now. Not that everybody is just carrying Tokumbo model all about. Enough, we have had a lot of Tokumbo car, Tokumbo model, Tokumbo people. Some of us are Tokumbo human beings. That thing has become, what's it called? Endemic. Do you know that? To the point that if you tell somebody, this biro is from US. Oh, I need that biro. That's the biro I want to be using. Why? Because you know that it's quality. Abi? So why not say that also we also be having Nigerian tea that people want to. I heard the other time that somebody say they took kuli to Canada and they are eating it very nice. So we can also import our model in there and they are using it. So that's the mindset we should have. Not that everything should now be, our own country should become a dumping ground for everything. Also, mortuary chicken. They bring them here, you chop up. So, who is interested? Who is interested? That's the issue. So, who is interested? So, in the course of developing the study concept, you must ask, who is interested in this thing I'm doing? Who is interested? Who are going to be your clients? Who is interested in, if at the end of all these things, who is interested? So it means that you must be able to link up with people that you can sell the idea to, the public health people. You know, I develop model now, now, to look for customers who are interested. Not just developing model and when we did the first work, I sent it, the first paper that was coming out this year, I sent it to NCDC. Yes. They are the customer, monkeypox. They are interested. The next, as soon as I sent it, the PA to the DG said, we need to talk. Please, let's talk after this salary break. I've not had time for him since then because I'm busy with this one. Maybe after this one, I'll begin to. So, people, you should find that what I'm doing, who is interested? Who is interested? Not just doing research. Say, publish papers. But nobody is using it. Are you getting me now? Knowledge that cannot transfer to help the economy. It's a waste. So you have done all the labor, sweat, all the mathematics, all the rigorous analysis, and nobody is using it. Nobody is using it. It's a waste. That's not the way people are working abroad, though. When they do any work, there are people who want to pick it up and use it. It was when I was when I was doing my postdoc, I found out that I was checking the files of the office I was working, and I saw how pharmaceutical companies, they were bringing jobs to the modelers in my center, and they were consulting for them, solving. I solved files of many problems, mathematical modeling work, pharmaceuticals, all these Roche, all these Novartis, all of them, they are using them. Mathematical models. And that's the one we are wasting away here. The only thing you are doing is that, I published 59 papers. And then nobody knows, nobody, those papers are not influencing anything. So who is interested in what you are doing? That's the next thing now. That's the next revolution. Who is interested? You must take it to the doors of public health people, nutrition, people who are in nutrition, people who are in medicine. They should be able to see the relevance of what you are doing. And that's when we can begin to have synergy, networking. We begin to say, this thing can be done in Nigeria. We want made in Nigeria model. And then people are doing it because the drug that's being produced is going to be used by our people, black people, not white people. are in this environment. So if we factor all the factors that are here into that model, it will work. Can it be narrowed down to a question without specific quantitative relationships? Those are the things we begin to think about. Now, I developed just one aim here. Now, just an example. The aim of this work is to gain insight into the relationship between ecological factors, human diseases, and economic development through the case study of Plasmodium falciparum malaria in Nigeria. Did you see any method there? Did you see mathematical model there? In that aim? The aim should not come from method. It should come from the biology. Now, the objective I'm writing, you see the objectives. Understand the effect of environmental factors on PF malaria ecology. The next methodology is, objective. Study the transmission of PF malaria from the aquatic environment to humans. Understand the feedback between poverty and PF malaria. You see now? And that's what I'm going to develop model on, like this one now. It means that my model is going to have some environmental factors inside. Are you getting me now? I'm going to factor things like, what are those environmental factors? Like land use. You know, there's a difference between environmental factors and climatic factors. Air quality, all those things into the model. Right? Especially on the aquatic state. That's a mosquito aspect. So, those are things. Then, study the transmission of PF malaria from the aquatic environment to humans. So, these are things we can look at. Now, literature. Who has tried to answer this before? And that's the first thing you are going to ask yourself. You are having an idea. A gap is coming to your mind. You have to ask yourself, who has done this before? Who have answered this question before? Are you the first person that will be doing it? And then, how did they do it? If there is somebody who have done it, how did he do it? Go and check his method. Check whether he carried out empirical study or modeling studies. Check. Some of these things are important. Who has done it before? And then, what are these studies' shortcomings? What are the limitations in this study? That's the way to write a modeling paper. What are the limitations in these studies? Are there already parameter estimates or data sets to help you answer your question? Do you have ready-made parameter estimates or data sets? What are those ones? So what are those ones I don't have that I need to now estimate? Find out. Data collection. What do you need to characterize? What do you need to describe? Do you want to describe at spatial level, spatial dynamics? You want to talk about the geographical location of the disease. You want to deal with it from the spatial point of view. You are looking at Benue and Kogi states. You are looking at Benue and Nasarawa. Or you are looking at Benue, Nasarawa, and Kogi states because they share border. And then you want to see the internal dynamics of malaria and external in terms of how people move from those places, inside and outside. How does it affect migration? Or you want to just look at it from the temporal point of view, just time, over time. The impact of seasonality and all that. Or relationship between parameters. You want to characterize relationship parameters of systems. Then construction of model framework. What drawbacks of previous studies can I mitigate? Drawbacks. Some things that they have done before that you can do now. What are the drawbacks in what have been done? In terms of even the model. Maybe the model they have done before is having some issues. Based on the biology has improved. Are you getting me now? I was reading some papers of modeling some few years back. Then I can see that the biology they are speaking then is not the same now. So you have to update your biology to update your model. So what type of modeling is necessary to answer my question? These are things you must ask yourself in the course of writing the modeling paper. Is it statistical? Do I need to start with statistical model? Or generalized linear model, GLM? Or spatial model? Or time series, depending on the data you have? Maybe you need to start from statistical model, just like we are doing in our center. And then from there, we are able to see the patterns. We are able to see many things. And then we graduate into mathematical model. So do I need a population-based model or individual-based model for this particular study? What modeling elements are necessary for my question? What modeling elements are necessary for my question? Now, do I need stochasticity? Sometimes it may not be a fully blown stochastic model, but you may need to induce stochasticity to some parameters in the model because they seem to be unpredictable. And then compartmental and complexity. So you want to introduce compartmental model, but with heterogeneities. That's the complexities there. Or what models best fit my data and explain my question? That's another aspect. What model best fit my data and explain my question? So, in answering that, you need to do comparison. That means you may need more than one model. You may need to build maybe 2, 3 models, and then you are looking at which one best fits the data. Model assessments, and under that we have model comparison of alternative models and application of selection procedures. So if you have 3, 4 models, and then you are now using AIC to pick the one that is best out of the 3 or 4. And then, does the selected model suffer from any substantial drawbacks? The one you finally select out of those 3, do they suffer any substantial drawbacks? You need to ask yourself. Now, drawbacks in terms of statistical model, verification of model assumptions. 2, mathematical model, sensitivity analysis, and out of sample predictions. Those are the ways you can check the drawbacks. Now, what are the main results that manuscript writing now? Finally, manuscript writing. What are the main results? What are the main results that provide the answer to my question? What are the main results? You have to picture them and explain them. So maybe you have 1 to 3 graphs. Because now, the question you are trying to answer, there must be a result that follows. Maybe you want to see the impact of climatic factors. Maybe temperature on malaria transmission in Nigeria. Now, at the end of the day, there must be maybe some graphs that are showing that result. That you are going to explain how temperature is influencing malaria in Nigeria. So you have to 1 to 3 graphs and then 1 to 3 tables that shows that kind of result. Then, what is the journal that best fits my study? Is it mathematical based journal or journal that is focused mainly on the biology of the disease? So you have to check the scope of the journal. You read about the journal, the scope. What do they publish? Then audience. What is the target audience they are looking at? Maybe the journal, you know, it's people that are in public health, they look at that journal very well. You know, there was a man in this country, Professor Tomori. He used to work, you know him. Okay, he's a virologist. He was just doing his work, but he was doing something meaningful. He was at UCH, University of Ibadan. So he was doing his research, just doing something meaningful in Nigeria on major diseases like Lassa fever, all those viral diseases and all that. And then, because he was putting his papers where the audience is targeting, we go. Like public health and all of that. So one of these days, WHO, they just phoned him, they just called him. As a lecturer at University of Ibadan, they just called him on phone. We have seen this number of your publications please, can you explain this? Can you explain that? Can you explain this? Can you tell us this? Can you tell us that? He gave them all the answers. And then after the interview, he told him, we are very sorry, sir. We knew that we have taken much out of your research time. How much do you think we can pay you? The man was surprised that, what are you talking about? This is what I'm happy to do. You are even, contacting me on my research. That's a good one. So the man felt, he's not thinking about that. So eventually, they looked at the time that they have engaged him, and they paid him in dollars. Now, at the end of the day, do you know what happened? They made him the WHO regional director. Yes, Southwest, on some certain projects. And that was how the life of this man got transformed. Why? He was doing research that is affecting his community, both locally and globally. Yes. So, how could we? You see, the day I heard that statement, it triggered something within me that I must use my maths to affect my community. Yeah, without serious, he didn't go to anywhere. He stayed here in Nigeria, but he's controlling still global. Let me tell you, if WHO want to do, when during Ebola, he was the first person they contacted. He was the first person, and he's a Christian. So don't think that if you are doing, no matter the religion you are, don't think you cannot use your education to affect people in your environment. You should think beyond the box. No matter the religion, even if you are a Muslim, you are a Christian, have the mind that you must use this thing to affect people in your generation. Don't do a research just to say, I was on the platform of mathematics and this thing, African something recently, and somebody said, I need a journal that can publish within one day. Maybe they are doing promotion. You know, it's promotion time now. So some people were suggesting different kind of journal for him. You know, you will send it in the morning, by evening, publish. You can send like 6 there, 6. And then you go to ARPC, publish, under one day, 24 hours publication. Onshore, this one is offshore. Offshore. There is no onshore there. Offshore. So those kind of paper, who will use it? Who will use them? That's why we have a bunch of paper. You see, somebody has just few papers, and they are calling him. That's the kind of, that's my tribe. Those are the kind of people I want to work with. Not just you are having dozens of papers and then it's not useful by anybody. Nobody think of using it. You know, I don't know. For me, I'm tired of that anyway. I don't know about you. So impact factor. You also talk about impact factor when you are choosing journal, and then what is the focus? Is it math focus or epidemiology focus? How do I present my manuscripts? So you start from introduction, set the stage to your question, methodology, describe explicitly all steps for replicability, results, clear and concise. Now, you must be able to describe your methodology to the point that somebody can reproduce the same thing. You don't just write methodology and close up some things so that nobody will be able to use them. I have some lecturers like that. When they publish, say, I remove all the major detail, keep them, so that nobody will use the work. Yes, I have people like that when I was a student. So, results, clear and concise. Discussion, explain how your study improves previous knowledge. So you have to, under discussion you are discussing, you are not concluding. No. That means you must be able to relate your present study with the previous studies and check what is it that is in your work that is not there, what is it that in their own work that is not in your own, and you are having a kind of relationship. Thank you very much.